I'm going to be, as soon as we get this up, we'll be talking about what I'm going to consider pressure points. Things that will hopefully provide an impetus for change of how we graze the American West. And I have a colleague back at Oregon State University. He's actually a civil engineer. And he has indicated to me many times, we've had great discussions about how do you get institutional change? And I would consider public land grazing institutionalized in the American West. And his thesis is, and I would agree with him, that you need multiple pressure points. You have to come at it from several ways. One entity cannot create change, but hopefully with multiple entities we can make it work. So that's kind of where my title comes from. The other thing I need to acknowledge is my co-author, my co-contributor, whatever here. I've known Boone for quite a while. We've worked together a lot. And while I'm here presenting, he's in Europe having fun. So I don't know who came up with the short end here. But anyways, I appreciate being invited. And this is really quite a nice facility that Utah has at this point. So let's get into this and see if we can. Oops, this is not working.
If you go to the down button.
Down button, thank you. These are always different, thank you. Okay, so very quickly, our situation is grazing is the most prevalent land use on public lands in the American West. It's, I have friends that go around and they say it's everywhere, and I agree with them. It is everywhere, almost. Most of our public lands see grazing year after year after year. And this is an allotment map put together a number of years ago. It gives you a good idea of what's going on. The white areas are there. A lot of them are public lands in many cases, and they are grazed also. So you can, some places you can just make this a continuous grazing map. So what I'd like to do is look at three, what I would call pressure points, or places where we might have drivers to encourage change of grazing on public lands in the West. And I've picked out three which I would consider to be quite important today. And these three would not have been on my list 25 years ago. Okay, this is 25 years ago, if you asked me to give a talk at this, at a place like this, these three would not have been on my list. Okay, but they are today, obviously. Climate change is a crisis. We have a biodiversity crisis, which relates a lot to beavers. It also relates to wolves. And so I'd just like to work through in the few minutes I have these various topics. And it'll be pretty brief because we don't have a lot of time here. The climate change one is a big one. And it encompasses just a lot of topics. Herbage removal is involved, trampling, trailing, affects soils, affects biological soil crusts, dispersal of exotics, exotic plant species that cattle and livestock move across the landscape, changes the diversity of what's out there. And then of course we have how these livestock process the forage that they take in. And of course we realize that greenhouse gas emissions are part of that. So as we look at this, it gets even more in-depth and more complicated. We can talk about altered fire cycles, increased erosion, altered soils and hydrology. My background originally has spent a lot of time in hydrology, and these are major changes that have taken place on grazed lands in the American West. We end up with altered competition interactions of species out there, particularly grass and forb species, but also the wildlife that takes place, and increased greenhouse gas emissions. So the topic of climate change really drags livestock into the picture in a multitude of ways. There's just a multitude of topics taking place. And as we move down this ladder, and I realize this is complicated, there's a lot of issues going on here, but one of the things we end up is simplified vegetation structure on landscapes. We have simplified ecosystems when we have intensive or extensive cattle grazing taking place, or livestock in this case. We end up with lowered biological diversity, degraded stream systems, and a decline of carbon stocks. And all of these are detrimental with regard to how these landscapes can handle climate and how they may actually contribute to climate change. And so when we get to the bottom of this little list of issues that we put together here, livestock grazing exacerbates climate change by creating desertification of sites, okay? Increased drying them out, if you will. Lowered resistance and resilience to climate change takes place, so they're less capable of handling any changes coming into the future. And we have lower carbon sequestration, higher greenhouse gas emissions when we're grazing these landscapes. So there's this portfolio of issues that are sitting there that are related to livestock grazing, but they all tie into this idea of climate change. And we end up with, we're losing options for the future, and we actually have lost options for today. But it's really, you know, I can't change what we've done up until today, but it's the future that we're looking at. And so change is needed if we want to get ready for the oncoming changes in climate that are about to occur. This is also, all these issues are exemplified perhaps in this little simple Venn diagram showing where forage consumption takes place. This is a recent forage allocation resource management plan put together by a federal agency in Southern Oregon, and you can see livestock at 86%. And the rest of the species, like deer and pronghorn, get 8%, elk get 2%, bighorn 1%, and feral horses 2%. So there's a couple of messages here. One is obviously livestock is the big user on our public lands, at least in this particular location. But there's another message here too, is basically we've turned our public lands into ungulate farms, whether it's exotic domestic livestock or the combination of livestock and ungulates. Most of what goes on out there is for the benefit of ungulates. And these other wildlife right here that get 1% are over 300 species. So they get the 1%, they get the residual. So when I'm just going to, a couple examples, and some of these pictures are familiar to you, at least to some of you, and give you an idea. But the A panel on the left is what happened on this site was intensive grazing. We lost the riparian vegetation. We got channel incision. We converted a perennial stream into an ephemeral stream. This very deep channel here, and on the right-hand side, we also have an incised and widening stream, again, due to intensive grazing, loss of vegetation, and trampling impacts here. And stream incision is probably one of the most common signatures of grazing across the American West. Okay, I see it almost everywhere. And so when you're wandering around out there across landscapes, look for over-widened streams, look for incision. This has happened. These systems are recoverable, though. There's some good news here associated with this, but the bad news is this is the status of a lot of streams. One more example. This one, again, in this case is an Oregon example. In Southern Oregon, we have the Heart Mountain National Antelope Refuge, and like most refuges in the West, it's grazed. It has been grazed. Livestock came on in the late 1800s and had been there for about a century, up until about 1990. And so the status of this particular site, you can see here, incised, over-widened. We have a dry meadow where we formerly had a wet meadow, and we see the total absence of woody species along here. The woody species you see in the background are fenced. They were fenced out, and that's why they still survived. It was just a little local spot there that was fenced, excluded from livestock. And we've got aspen there, and we got willows there, and we've got great grass species and everything else. But where cattle have been present, we see great changes have taken place. That's the bad news. The good news at Heart Mountain is that we've seen recovery take place. In 1990 was the last year that livestock were used on this particular national refuge. 250,000 acres were excluded from grazing after 1990. That's a big chunk of land, but it's not big in comparison to the rest of the West. But we're finding that it's really been pretty interesting watching the changes that take place. We see things, for example, the recovery of willows, very robust willow communities. The stream channel is now almost invisible. You have a hard time finding it because it is narrowed up, has lots of shade, all that. Where we formerly had a dry meadow, we now have wet meadow, and we have wet meadow species growing there. So there's been this incredible recovery. 30 years is all it took of non-use by livestock. Pretty amazing, pretty amazing. Not only have riparian areas improved and recovered, but we've also seen some major changes in our upland aspen stands. The upper panel here shows you what it looked like in about 1990. These stands were coming apart. And this picture, unfortunately, is all too common in the American West. Aspen stands are in trouble in a lot of places. And you can see there's no reproduction there. If we look down at the middle panel, right here, we can see you can see the overstory is falling apart. Aspen lived to about 140 maximum, maybe 150, so these old trees can only hang around so long, then they're coming down. And the lower panel shows you a few of these remnant overstory trees, well over 100 years old, and then you see the recovery of the new aspen coming in, all since cattle had been removed. And so the aspen in this picture, the older ones grew up, were established when cattle were absent on the landscape. Then cattle came in, they could not grow, and now we're seeing aspen here growing again in the absence of cattle. So those aspen are all there, occurred in the absence of livestock. And when livestock were present, this is our story up above. So again, there's great recovery potential, but it requires a change of use. So a couple of closing comments on this topic anyways, that grazing can cause a variety of ecosystem effects, many of which contribute to or increase their susceptibility of these sites, of these systems to climate change. It's a huge issue coming forward. We are indeed in crisis mode. However, again, many Western ecosystems are resilient, and the removal of livestock allows for their functional recovery. Riparian areas and aspen stands are some of the quickest to come back. And I've had discussions with my range management colleagues at Oregon State, and they tell me they can graze and improve riparian areas and all that. And I keep encouraging them to show me, to prove it to me, to show me where you can do this and then implement that across the West. And what I would suggest to them is I can do it too, and what I will do, how I will do it is by removing cows, and that's a solution they don't usually want to talk about. So let's shift gears. Beavers, and this is a biodiversity issue here, and it's come on the scene rather recently. Beaver were once abundant across the United States. They disappeared. They were some of the first animals to disappear in the eastern United States because they were worth dollars. Okay, they went quickly. In the West, it was about in the mid-1800s that we finally almost got rid of all our beavers. We came pretty close. Functionally extirpated means they were still a few around, but basically, ecologically, they were unimportant. They were remnant populations. But the science has been telling us some interesting things of late. If you just do a Google search and look at beaver, Castor canadensis publications, this is kind of what's going on. It's been in the last 20, 25, 30 years that we've seen this mushrooming of publications on beaver take place. And basically that says new science in a way. It really says the science community is now doing something they hadn't been doing before, at least to that extent. There's another aspect to this science, if you will, and that is what are they focusing on? And this is just a look at keywords associated with publications on beaver. And for example, the very first one bar on the left is just the term ecology. Over 70% of all Castor canadensis publications also include the word ecology. So that's showing up. And the rest of these also include words like fish, habitat, diversity, ecosystems, biodiversity, fisheries, riparian, channel, wetland, pond, sediment, trout, hydrology, salmon, waterfall, water quality, and amphibians. Again, a biodiversity issue. Beaver are increasingly being recognized because of their biodiversity importance. And it all begins with a very, very simple little structure, and it says beaver dam. A small mammal creating a small dam begins to work wonders in our stream systems in the American West. Works wonders in the American East too, but our focus here is on the West. One more example here maybe of what can happen and how quickly. This is a stream in northern Yellowstone Park in 2006. Glen Creek is just a channel that runs along through this particular valley bottom. In 2014, Google Earth, you can go find us yourself, and you can see that a beaver dam here, and there are some other smaller dams in here, has begun to change the hydrology of the system dramatically. The amount of water that's being stored, that's taking place. What you can't see is up here in this corner is a vast young aspen stand coming in. And what's unique about that is it's all aspen seeding. They seeded in at the same time these beaver came in and changed moisture conditions. So this is the biodiversity component that these small animals are capable of changing out there in the landscape. There were no aspen there before, but now we have this extensive aspen stand of seedlings coming in. And those of you that have worked in aspen at all know that established seedlings are a rare occurrence in the American West, at least of any magnitude. So this is a big deal. So when we look at the benefits of beaver dams, and it's the dams, they create ponds and wetlands, they spread water, they store groundwater, they help create this thing called hyporheic flow, that is water moving out of the pond subsurface and showing up in the stream down valley, changing the character of the water as it does so. They trap sediment, they grow a diversity of plants and store carbon. So they're important in climate change issues. They create habitat for native fish and other aquatic organisms. In the Pacific Northwest, we pride ourselves on salmon, and yet I've been amazed at the lack of support by our state fish and game agencies on getting beaver across the landscape. They seem to like to continue to trap and hunt. And to get beaver widespread in Oregon is like pulling teeth. But we used to have them in very abundant numbers. Most states in the West had them in very abundant numbers, but today they're relatively scarce. We need them back. They create habitat for terrestrial wildlife and birds. Again, they are these biodiversity pumps, if you will, on the landscape. Incredibly important. They provide fire breaks in places, and they moderate the effects of climate change. So a huge list of pluses that come from beaver. So again, just to emphasize, they greatly increase this biodiversity component. We have a climate crisis going on. We also have a biodiversity crisis going on. Beaver can play a role in that because they increase the biodiversity associated with streams and riparian areas. But they currently remain relatively scarce in the American West. So those numbers need to come up. The conflict here with regard to livestock is livestock can suppress the growth of woody plants. And these are the food resources for beavers. So if you want to keep beaver out of a system, maintain little or no woody species in riparian areas with livestock grazing, and you can be effective forever. And this is going on in a lot of places. Grazing just perpetuates the lack of beaver in these systems. And so this is a big issue. Oregon's trying to work through this right now. We have a proposal on the table to exclude all publicly managed federal lands in the state of Oregon, 53% from the hunting and trapping of beaver. It's like pulling teeth, but we're slowly working towards that. Whether we will be successful or not, we don't know. But that's the target. At least half the state would like to see devoid of all hunting and trapping of beaver. We think they're a big deal. The last topic, very quickly, is wolves. And this has certainly come on the scene in the last 25 years because prior to 25 years ago, we didn't have any wolves in the West. They were absent. Actually, most of the West went barren of wolves sometime in the early 1900s. Whether you're in the Olympic National Park or in Yellowstone or most places, right about early 1900s is when we just seemingly got rid of them all. And we could ask the simple question, and actually this is part of the research that Bill Ripple and I have been doing for the last 20-some years. We have a very simple question. What is the ecological importance of having wolves or other apex predators on the landscape? In other words, what happens? Is it important? Does it make a difference if we take them out of the system? And back then, we didn't know exactly what the answer was. And so what we did is we wandered around. We took a national park tour. We went to Olympic National Park. We went to Jasper National Park in Canada. We went to Wind Cave. We went to Yellowstone. And these are wolf elk systems by and large. We also went to Yosemite and Zion, and these are cougar mule deer systems. But what we found as we wandered around and asked the same question, what happens when you remove an apex predator? We found In every case, the local native ungulate began to dominate the system through herbivory, and began to change everything. And so native species, plant species, were beginning to have a tough time. It was the common response everywhere. So that would kind of indicate that it may be important to put this predator back in the system. I'm just going to give you a little bit of the Yellowstone example because we've worked so much on it and we have a good feeling for what's going on here. But the story here is a simple one. Wolves were extirpated by the mid-1820s, and afterwards, in this case, the elk took over, began to browse everything: aspen, willow, berry-producing shrubs, alder, you name it. Those plants could not get any higher than about 50 to 100 centimeters. So 1 meter tall at the most, but most of them were knee-high, could not get any higher than knee-high. And that's a pretty remarkable effect on an ecosystem when an ungulate, one bite at a time, can basically bring it to its knees. And that's what they were doing. Then the flip side is, of course, wolves were reintroduced in 95-96, after which we saw elk browsing declining and riparian vegetation and aspen stands beginning to recover. And the simple picture here is, in the absence of wolves, again, elk were in charge. They basically could walk up to any plant, stand over it, browse it as long as they want, take it down to the ground, and that was it. Those plants could not grow any higher than your knees, roughly. With wolves back in the system, they now are the pressure point on elk and control, in essence, control or mediate with the effects of elk, and we are now seeing recovery or the improvement of growth by young woody plants, whether it's aspen or willow or whatever. So this is this concept of a trophic cascade. These upper trophic level wolves affecting the next trophic level down, affecting the next trophic level down, which are the plants. And this is where wolves and other apex predators and a predator guild, if you will, play that important process. An example, just one example I'm going to show you here. I've got a bunch of them. Unfortunately, this is a little bit dark, this screen, but over here on the left, this is the spring of 96. Wolves had just been reintroduced into the park, 95 winters and 96. But look at these willows over here, and those are about knee high, and those are about the tallest willows we have along this channel. The rest of them are all shorter than that. So this is what willows look like in Yellowstone in 1995-96, everywhere. And that's what aspen looked like, everywhere. Nothing could grow. Okay, we fast forward to spring of 2008. The willow that you see here is this one here. It's a little bit dark. Unfortunately, we got these lights on here, but right here you can see it's about waist high. It's improving. It's getting a bit taller. Likewise, other willows in the system, are getting a bit taller. And so this is 2008. If we move up to 2014 and we look at in the summer, this is what we get. So trophic cascade, does it make a difference? On the landscape, this is what it looks like. Okay? Now, if streams in the American West look like this example, and not like this example, I'd really be a happy camper. In fact, we probably wouldn't need this conference. We could all go home, or we could go to the brewery tonight and just have a good time. But unfortunately, we're still here. We're still over here in many places. That's unfortunate, really unfortunate. It's worse than that. A cartoon, if you will, but this is a graphic in a National Geographic. The artist's rendition, the version on the left is what you get when you have no wolves in the system. You have lots of elk. You have very impoverished stream ecosystems. You have channels that are widening and incising, and you have woody species that can't grow. And if you put the large carnivore back, wolves in this case, and we do have a complete carnivore guild in the park. We have cougar, we have bears, and so on. But in this case, what we're seeing is improved waterfowl, amphibians, beaver are returning, pronghorn are doing better, bears are doing better, elk are still present, by the way, birds and scavengers are doing better. A whole host of species are doing better. And so when you look at these systems from the standpoint of wildlife, the question is over here, what other wildlife are having an advantage when you have an elk-dominated system or a livestock-dominated system versus one where you have incredible diversity in plants? Okay. Now, there's a caveat to the Yellowstone story, and it's an important one. We're seeing a lot of success with regard to wolves and willow and aspen and stuff like that going on up there. But there's some places where it's not occurring. And those places are places that the public sees a lot of. And if you've ever been to the Northern Range, you've probably driven through the Lamar Valley. And the next time you go to Lamar Valley, or if you've been there, this is really what you're seeing. You're seeing a lot of bison, and you're seeing bison impacts. If you close your eyes and just think about cattle impacts, that's essentially what we're getting. We're getting the effects of a hyperabundant livestock, if you will, inside the park. We have eroding channels here and here. We have springs and wetland sources that are just being trampled, heavily utilized. And the conifers that have been around for hundreds of years, in some cases, are on their way out. And so within the next 10 years, you will probably be able to drive the Lamar Valley and see nothing but dead conifers standing up because they are being barked by bison. It's all happening, and it's all a big deal. And the Park Service wants to put more bison in there. Now, I like bison, but they're just, when you put big populations in a constrained place, this is what you're going to get. And that's what's happening inside the park. So my solution is they should move them to the Great Plains, but we will see. Park Service has their own ideas. So when we go back to the wolves and livestock issue, though, we do have a bit of a success story going on. 25 years ago, this map would have been blank of circles. I would have had no blue circles. And these are just approximations of where wolves are at in the American West as of a year or so ago. I don't have the most recent circles here. But you can see we went from a map that was blank, let's say 25 years ago, to one that now has blue circles on it. So we've got wolves across at least parts of the West. Keep in mind that wolves were across almost the entire West. So we're not quite close to where we once were. And you can see that also there are conflicts here with regard to grazing allotments. And not all wolves will create grazing or problems with ranchers, okay? There's a lot of ranchers that don't have wolf problems. But you can see that the overlap is occurring, and if they expand their range, the overlap will become more important. And so I guess there's a challenge here for federal managers to think about that and things they can do. For example, if they realize that they've got wolves denning in a particular location, don't put the cows out quite so early, or don't put them out at all. Move them to a different allotment if at all possible, or permanently close the allotment. That would be even a better solution. So there's a real need for federal land managers to start getting involved in this issue, even if we can't get all the livestock off, at least to begin to adapt to what's going on out there. So if I could wrap this up real quickly here, wolves were historically important component of Western ecosystems. Again, they were throughout the West, but we did our very best, and we extirpated them. We gave the government a job that it could do, and it was successful. It got rid of all the wolves. Some recovery has occurred at least of their original distribution, as that map showed, but reduced livestock grazing would assist in their continued recovery. It would be a really important thing if we could pull that off. So very quickly here, these pressure points, and here's a brief list, and we could add some more, I guess, here. But maintaining healthy watersheds is one of the things that would tell us we really don't need livestock on a landscape. Maintaining or improving biodiversity, storing carbon, reducing greenhouse gas emissions, preventing desertification, recovery of functional beaver populations, boy, that's an important need, and recovery of functional wolf populations. All of these represent to me pressure points for change. And these are ones that have come on, some of these have come on the scene relatively recently. Supporting literature for those of you that want to delve into that. And my last slide, ta-da. as I was about to be dragged off the podium. A comment from Aldo Leopold, and he was talking about national forests and parks and the aesthetic death of a piece of wild country once they get, once you anoint a piece of ground as being important. We might also anoint areas that have been livestock grazed for the last 100 years as aesthetic death also. They have changed dramatically and are in dire need of recovery. So thank you.